Hello and welcome back to my channel. Today we'll be looking into the data structures and algorithms course. So today we'll be focusing mainly on the binary search algorithm. Now, what is the formal definition of a binary search algorithm? So in computer science, the binary search algorithm, it's basically an algorithm that uses what we call the divide and conquer principle. It will divide an array into two and then get its midpoint. And once it gets in its endpoints, it midpoint, it will take the contents of the midpoint of the array and compare it with the target value. But for us to be able to use this algorithm, they say that the array that we are working with or dealing with, it must be sorted. It must first be sorted, and again, we must be able to get the middle element of the array. So mainly the big thing that is being emphasized here is that there's a condition for us to be able to use this algorithm, and that condition is that the array must be sorted. All right. Now, to elaborate further on this, I'll just show you in this way. If we are given an array like this, if we have been given an array from 0, 1, 2, 3, 4, 5, 6, 7, and then 8 and 9, and then maybe we had 10, 20, 30, 40, 50, 60, 70, 80, 90, and 100. So they say that for us to be able to use this binary search algorithm, there's a precondition. And the precondition is that the array must be sorted. It must be sorted. If the array is not sorted, then you make it a point that you sort it first before you apply the binary search algorithm. It cannot work if the data that we're dealing with, if the array that we're dealing with is not sorted. So those are the preconditions. For us to be able to use the array, it must first be sorted. Now, after you've met this condition, uh, they say that you need to also find the midpoint of the array. So this array must have in the middle. How do we do that? Now, the this algorithm is also called the divide and conquer algorithm. So what it does is that it's going to come here and say, okay, fine, we have the left side, I'll call it L. And so L is going to be at index 0 the first time around. It's going to be at index 0. And then the right is always at the uh, index length minus 1. So the length of this array is 10. So its length minus 1 is going to be 9. That's where our right will be. Okay, these are the pointers. So this will point here, this will point there. Now, for us to be able to find the midpoint of this, there's a formula that we need to use, which is L plus R, left plus right, divided by 2. This is the formula that is being used in order for us to get to the midpoint of this array. Okay, so this also can be the same as left plus into right minus left, then divide this part by 2. All right, so L R minus L divided by 2 is the same as this. But this is the preferred way of doing it when you're writing code. Okay, so we will focus on this one much. But as of now, for illustration purposes, I'll just be using this formula. But when we write code, you'll see we'll be using this formula. Cool. Now, that means that if we need to find the midpoint of this array, we have to say, okay, fine, what is our left is 0, and then what is our right is 9. It's going to be 0 plus 9, which divided by 2, which is 4.5. But because we are dealing with integer values, it's going to be 4. Okay, it's going to count the 0.5, and then it's going to be 4. So at index number 4, that will be our midpoint. So this is going to be our mid. Okay, so now, according to what the algorithm explains, is that it divides it. So it's going to come here and come to the middle like this. This will be the middle, and say, okay, there are 3 conditions. Once the array is sorted, then you find the mid. You need to know there are 3 things, 3 conditions that you need to adhere to in order for you to get to your final destination. Now, what are those conditions? I'll just elaborate by stating those conditions here. Okay, so if value, the value or the target that we're looking for is equals to the contents of the midpoint, the contents of the midpoint. If this array was ARR, and then our midpoint is 4, as we have correctly saw, then our midpoint is going to be the contents of the location 4, which is the index 4, and then it's going to be 50. The contents of this is going to be 50. Okay. Now, if we find ourselves in a position whereby the target that we're looking for is equal to the midpoint that we are looking for, or the content of the midpoint, then it means that we have found what we're looking for. Then we just return the location at which that is. Then number 2 is that if our value is less than the contents of our mid, then it means that the value must be on the left hand side. Remember, if this array is sorted, if we are looking for 40, and we find that, okay, fine, at midpoint 40 is not equal to 50, it means that it must be somewhere on the left hand side. And then what we need to do is that we need to move R to here, because we'll be working with this left hand side, well, or the left part of the subarray. Okay, the binary search algorithm divides the array into subarrays. So we'll have the left part, and then we'll have the right part. So if the value is less than the contents of the mid, then it means that it's on the left. It means that we move R here, so meaning that R is going to be mid minus 1. And then otherwise, if value is greater than the contents at mid, then what do we need to do? We need to say, okay, fine, return, no, not return, but rather we need to say, okay, fine, if the value that we're looking for is greater than this, it means that the mid, it means that the leftmost, we need to deal with the right hand side, or this right subarray. It means that L must move this side, because we will focus on this one since the array is sorted. Okay, just move it. Yeah. So now L will move here, and then we'll have R that side. Okay. So it means that our left will be mid plus 1. Right. I hope that is clear. All right. Now, if we had to divide this array, I'll just divide it for you here. We'll have the left hand side, which is going to be from 0, 1, 2, 3. And then we will have our right hand side as 0, 1, 2, 3. And then we'll have our right hand side, which is 5, 6, 7, 8, and 9. Okay, so if this was 10, 20, 30, 40, and then just never mind this one. So it's gonna be index 4, and then we'll have 5, 6, which is 60, 70, 80, 90, 100. Okay, so this is gonna be 50. So we'll have our left part, and then we'll have our right part. Now, if we were told to look for the value 70, this is how we'll do it. Now we'll adhere to those three conditions. N is equal to 70. Okay, this is the value, the target value that we're looking for in this array. Now, well, this is how we'll do it. Okay, what is the midpoint of this? The midpoint of this array is here. Okay. Now let me just L R and then mid. So I'll do it this way, so you can all understand. I'll push it a bit up here. Okay, cool. Now we are looking for 70 as our target. So at first, we'll start off at 0, at index 0 as L, it's at index 0, and then R is at index 9, and then our mid was 4. Okay. Now we'll say, is N, which is equals to 70, equals to 50, the contents of the mid? No. Then we'll go to the next condition. Is value N less than 50? If it is less than 50, then we go to the left, but it's not less than 50. It's not less than 50. It's the value N, which is 70, greater than 50. Yes, it means that if it's greater, then it's somewhere on the right hand side, isn't it? Now, if it's somewhere on the right hand side because it's sorted, then our L will come and be here, and then we'll have L here, and then we'll have R like that. So meaning that now L will be at index 5, and then R will remain as where it is right now, which is at index 9, and then it's going to be 5 plus 9, which is about 14, divided by 2, which is 7. Now that means that our midpoint now is going to be at index 7. Okay. Now at index 7, it's 80. Our N is 70. Is 70 equals to 80? No. And then the condition is not met. Is N equals to, or this value equals less than the contents of the mid, which is 80? In our case, it's going to be 70 less than 80. True. Yes. Then it means that this has been further divided again, right? It has been further divided again. We have our 60 here, we have our 70 here, and then we have our 90 here, and then we have our 100 here, and then this is the mid, which is going to be 80 within, which is this one. Now we are saying that is 70 equals to or less than 80? Yes. Then it means that the value must be somewhere on the left hand side. Okay, so it must be somewhere here. Now if that is the case, then it means that the value 70 must be on this left hand side. Now we do the recursion again. Okay, fine. That means that our right must be mid minus 1, must come and be here at index 6. Okay, so this is going to be our this is 5, this is 6. So at index 6, this is 8, and then this is 9. So at index 6, it's going to be R, and then L will remain as is, where it is. It's going to be 5, it's going to be 6 here, and then it's going to be 5, it's going to be 6 here, and which is going to be 11 divided by 2, which is 5.5, which is 5. Now it means that the mid will also be at 5 here. And then we'll have mid here, and then we'll have L also pointing to the same place. Now the question goes again, is the contents of the mid, which is 60. Is 70 equals to 60? No. If it is not, then we go to the second condition. Is 70 less than 60? No, it's not. Is 70 greater than 60? Yes, it is. So it means that uh, now our L must move. Our L is now moving to where R is. So L and R are pointing to the same place, which is at index 6. So we're going to have 6 divided, 12 divided by 2 is 6. And then we'll also have our midpoint pointing to 70 here. And then the condition will go again. Is 70 equals to 70? Yes. If it is, then we'll return a 6. Okay, which is the location at which 70 has been located. All right. Now, that's in a nutshell what this algorithm is all about. Now, one might ask himself, how long does it actually take to complete a search? Okay, which is a fairly good question. How long does it take for it to? So now, how long does it take for us to search for something? Okay, so if, for example, n, let me just use a highlight. If n was 50, and then the midpoint is 50, the contents of midpoint is 50, 50 is equals to 50, then we'll return a 4, the location of where 50 is at index 4. So it 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 doesn't take time to actually arrive to this. All right, so what we'll do is uh, it means that the best case, so best case is as O of 1, big O of 1, so at constant time. So it doesn't take time to actually get this. Now, as soon as you maybe say, for example, you're looking for 100, if you are in a situation whereby you have to look for a particular value there, then you apply the binary search, you will have to divide and conquer. So it means you are halving the effort it takes for you to be able to search through the entire array. As soon as you are doing that, then we must speak of logarithmics. Okay, so the worst case for for us to search through this is at worst. It's going to be big O of log n. So this is the worst time it takes, and I will talk to you about it. I'll just prove how we actually got to this. But as soon as you are halving or you are multiplying the effort it takes, and then we are speaking of logarithmics, and then it's going to be O of log n. I hope this has synced deep. And in the next one, we'll just write some code. We'll just code this algorithm.